Thank you everyone for joining us today on this webinar. My name is Vikram and I am joined on this webinar by our senior engineer Mike Yang. We're very excited to talk to you actually because we just released our first 400 gigabit per second Ethernet testing solution. And so what we are going to talk about today is our ability to record traffic at up to 400 gigabits per second. So it's our latest product offering. It's called FastRecorder. And let's go ahead and start the webinar. I think you are all familiar with GL Communications, but just in case you're not, we are located right outside of Washington, D.C. We've been around for over 35 years now, and we do all sorts of telecommunications test and measurement equipment. We are a manufacturer of test and measurement equipment for the telecom industry. We can capture traffic, we can generate traffic, we can analyze traffic, we can store traffic on all these different types of network. Ethernet and fiber optic networks, SONET and SDH, legacy networks, radio networks, and so forth, cellular networks. We can do all sorts of different types of testing for all of these different types of networks. We supply equipment to telecom service providers. We supply equipment to equipment manufacturers. We also supply equipment to defense contractors, aerospace companies, as well as government. Okay, so 400 gigabits per second. What is that? So I'm sure you already know, but Ethernet standards continue to get faster and faster and faster. Networks are now carrying more and more traffic than ever before. You have super high-speed backbone links that are carrying traffic from data centers to other data centers and other core network infrastructure. And they're doing it at now 400 and even 800 gigabits per second over super high-speed fiber optic networks. 400 gig is an actual Ethernet standard, is based on the IEEE 802.3 standard and so forth. So it talks about how the data is transmitted and how and what the protocol looks like. So that's 400G. You're going to see 400G in all sorts of core network infrastructure. So in data centers and between data centers, you're going to see it in core network infrastructure connecting cellular towers and so forth. So it's used all over the place. It's used again in data centers and in telecommunications networks. It's used by financial services, you know, for ultra fast, low latency applications, so that financial companies can get very accurate, up to the second financial information. Other companies in healthcare space and all these other media and entertainment, they're all relying on super high speed links these days to connect to remote systems and services and so forth, and streaming and all that. So 400G is becoming ubiquitous. You don't see it at customer premises, like meaning, like personal premises like home networks and things like that, but you see it in the core networks. Okay, so our solution is all about capturing and recording traffic at 400G. So why would you want to capture and record traffic at these rates? Well, many reasons. If you're a service provider, you obviously want to make sure that your infrastructure is performing adequately at these super high rates. So you want to be able to verify network performance and verify service level agreements that you're providing to customers. If you're any sort of network engineering, you've got some sort of malfunctioning network infrastructure or overloaded network infrastructure, you want to be able to troubleshoot that by capturing packets and analyzing them and storing them and so forth. If you work in cybersecurity, you want to be able to capture traffic at these super high rates and be able to analyze it for anomalous traffic patterns to be able to quickly filter on IP addresses or different protocols and so forth to be able to identify rogue connections and other types of suspicious network traffic. It's difficult to do that when you have 400 gigabits per second flooding through a network. So you need a device that can filter through that traffic and allow you to see the needle in a haystack. So another thing you would want to use capture and recording solutions for is for network baselining. So if you want to understand what your network, how your network behaves on a daily basis, what type of traffic is going over your network, how much traffic is going over your network, who are the top talkers in terms of IP addresses and so forth. You want to gain a general understanding of your network by baselining it. And so that way, that ties into cybersecurity, because now once you establish a baseline, you can then know what is anomalous and what is suspicious as compared to what is normal network traffic. And then finally, network surveillance. If you're doing any sort of surveillance activity and you have to capture traffic at very high rates, you will need something that can do that, that can capture and record traffic. Okay, we have a system that we've built. It's the latest in our Packet Scan HD product line. We call it FastRecorder. It's on the screen here. We have both a rack mount solution and a portable solution. Both the portable and the rack mount solutions are custom built PCs. We have optimized everything about it. We've optimized the disk write speed, the cooling, the RAM. We're using our proprietary network interface cards to capture traffic at these super high rates. It's a very customized solution. And whether you get the portable solution or the rack mount solution, it's the same exact software, same exact capabilities. The only difference is, one is portable and one is rack mount. And also the rack mount, we can offer a dual processor, whereas the portable solution, we can offer just a single processor. We'll talk about that a little bit later. What's the advantages and disadvantages of the dual processor over the single processor system. But anyway, the point is we've got multiple ports on this system. We can have up to 400 gig ports on the system, whether it's rack mount or portable. So here on the left-hand side, we're showing a 2-port system. In the middle here, we're showing a 4-port system, and down here, we're also showing a 4-port system. These are SFP cages. They support all your SFPs and SFP pluses and QSFPs and single mode and fiber and multi-mode and all the different fiber optics that you can think of. We support it with using these SFP cages. And we also provide SFPs and accessories and so forth. So that's what the solution looks like in terms of the hardware. Let's now talk about what it can do for you. I apologize, there's a lot of text on this screen. You don't have to read any of this. Basically, we can record traffic at super high rates. We can interface to these 400 gig networks, and we can capture traffic in both directions simultaneously. We can record up to 6 terabytes a minute. And I want to mention that we can customize the storage in both the portable and the rack mount solution. So you tell us how much storage you need, and we'll put it in there. We can put up to, I believe, something like 240 terabytes of storage into the system. But depending on your requirements, you may not need that much. And depending on your price point, we can always lower the storage requirements and so forth. Anyway, We do non-intrusive continuous recording. So even if you start to fill up the disks, we can still record continuously by then going back to the beginning and overwriting the earliest recording. So we can record continuously. We can record from multiple ports simultaneously. Like I said, we've optimized the disk write processing. We write to all of the disks simultaneously, and in a very super fast way. We don't have any packet loss. We'd have advanced hardware-based filtering. So there's a strong likelihood that you don't need to capture all of the traffic at 400 gigabits. Maybe you just want to capture traffic with a certain IP address or a certain protocol. So we can filter, and we can filter at the hardware level, so that we do it at wire speed without dropping any packets. Nothing here is done at the OS level. It's all done at the hardware level, right at the onboard network interface card. So that way we are ultra fast and we don't drop any packets, and we can filter based on a whole variety of different protocol headers. Okay, we give you a ton of different metrics on what we're recording, how much we're recording, and so forth. Mike will talk about this stuff later on. He'll show you some screenshots. Okay, so how do you deploy this high-speed capture system? There's two main ways you can deploy it. One is by connecting to mirror ports on a switch. So that's this left-hand depiction. You connect to mirror ports on a switch. And then the beauty of that is you're non-intrusively tapping into the network. The mirror port is simply copying out traffic from all the other ports and sending it to our system. So we're not tampering with the data. We're not breaking the data or anything like that. We're just getting a passive copy of all the data from the mirror port on the switch. The other way to do it is to use a network tap. So with the network tap, you plug the tap in line on the network. So you temporarily break the network, put the tap in line, and now you're seeing everything that's going through the network. And then you use the mirror ports on the tap to copy the traffic out to our system again. So you can use a tap configuration or a mirror port on a switch configuration to capture the ultra high speed traffic. So there's advantages and disadvantages to both. And we can talk about that more if you're interested in it. Okay, so I also want to mention this is a very scalable solution. You can actually have many of these FastRecorder systems deployed throughout your network, and you can connect to all of them simultaneously and through a very simple web-based interface. So from one web-based interface, you can connect into all of these high-speed capture systems. You can start captures, stop captures, view real-time graphs and data, and so forth, save stuff, and so on. So that's very nice. No limit, really. You can deploy as many of these systems as you want across the network, as long as they can talk back to the web server. So you'll notice that these systems, they have their own built-in Ethernet port. It's a gigabit Ethernet port, and that Ethernet port is for remote management only. So you connect that into the network where it can talk back to the web server. So that Ethernet port is not for the high-speed capture. That Ethernet port is for management. And so you connect it back into your network, and then from the web GUI, you can see all of your systems in real time. Okay, a little bit about the system. Again, it's a custom-built system. These are all these NVMe SSD drives. Again, we can put as many of these as you want into the system, and they're very easy to pop in, pop out. So if you're going out into the field, you need to take a recording, and then pop in or pop out a drive, put in a new drive. Very, very easy to do that. So some customers like to use the term tactical recording. And it's a tactical recording solution because you can take it into the field, pop in a drive, pop out a drive, and get your recording and take it back with you. Okay, so we can actually go up to 20 of these NVMe SSD drives, and each can hold 30 terabytes. So that's how much storage we can pack into the system. We can capture at a total rate of 100 gigabytes per second. We're capturing again on multiple ports. This is a Linux-based operating system. If you're familiar with our products, most of our products are Windows-based, but due to popular demand, we've decided that for our 400 gig solution, we are switching to Linux. So this is now Linux-based. It has a redundant power supply. And again, I mentioned it has an Ethernet port for remote access. And it's also got HDMI ports here and USB ports for local access via monitor, mouse, and keyboard. And again, the rack mount system has a dual processor. The portable system has a single processor. You know, we wanted to prove to customers that we are true wire speed without any loss, and we can do it for a variety of frame sizes. So, snapshot of our internal testing, we tested at a variety of different frame sizes. From 500 to 1,500 byte frame sizes, and as well as a mixture of different frame sizes. And in all cases, we can capture 100% of the traffic without loss. So whether it's a fixed frame size or a mixture of frame sizes, we are capturing without loss. For the portable solution, we will provide a Pelican case. And we have made a custom foam cutout for the Pelican case. And this is very convenient. You can put the FastRecorder system into the Pelican case. It also has extra space to put all of the accessories. So the fiber optic cables, the SFPs, and so forth. It has extra space, so you can put all of that into the Pelican case. The Pelican case is very durable, very rugged and solid. It won't, if you can, bang it around, you can put it on an aircraft, you can do all of that. It's very secure. The system will not get damaged. It's got wheels, it's got a handle, very easy for mobility and portability. So we provide this free of charge with purchase of the system. In fact, we ship it to you in this Pelican case. Okay, so that's a high-level summary of this high-speed capture system. I will now turn it over to Mike, and he's going to run through all of the user interface and give you more information about what the system can do for you. You can start, Mike.
Thank you, Vikram. Yeah, so I'm going to give a sort of an overview of our web interface for the FastRecorder and as well as the packet extractor. I think we haven't really discussed that part yet, and I'll talk about what that packet extractor does for us. So on each of these capture systems, since it's a Linux system, we're running this web server natively on each server. So you can just go to a browser, type in the IP address of the server, and then you can control the FastRecorder. Because it's a web server, from the same instance, you can actually control multiple FastRecorder servers from the same instance. And I'll show you how to do that through our GUI. So the first time you log in, you'll see this login screen. We can configure users. Multiple users can access the system at the same time. In this case, we're showing an admin user and the password. Okay, so once we're into the web interface, here we have a server setup tab. So you see here in the middle of the screen, it says server 1 with the IP address of 192.168.30.122. So that's the server that's already configured, and you'll see there's a server status saying FR active, FR meaning fast recorder, and then PE active, PE meaning packet extractor. You'll see that there's ports that we've listed here. These are actually, so the fast recorder is a server or a server or service that's running on the server. Same thing for the packet extractor. So the listening on those two ports, that's actually a REST server, which means we can have REST APIs access the server as well. So you can, for example, have Python scripts that can control the fast recorder, the packet extractor, start recording, stop recording, things like that. So if you want to automate any of these tasks, that's all doable through an API. So that's the server one. Now, if you want to control another fast recorder server, you can add a server two there with a different IP address, port number, so on, right? So you can add that second server, and then from the same web interface, you're able to control multiple servers. So now we're going back to the dashboard. So this is where you sort of control your fast recorder settings. So we have configuration, hardware filter, statistics, and graphs. The statistics and graphs will show you the information as we're recording live information, so packet counts, throughput, things like that. So in the main configuration page, we're gonna give the recording name, and then the total record limit. So that just means the total size that you want to record. You have the option of stopping the recording after a certain number of gigabytes is captured, or you can choose the keep latest option, which essentially does a circular buffer, so it'll keep the latest X number of gigabytes that you choose to record. And that record limit is based on the total number of NVMe SSDs that you have available in your system. When we write to disk, when we capture these packets, we're capturing as sort of raw data, and we're scattering these packets into all of the SSDs simultaneously, or at least all of the SSDs that you choose to capture on. We'll spread it across all of those disks. So we're taking the combined storage size of all of those disks as the sort of the total storage limit. So for example, if we have 20 of the 30 terabytes, right, you can record up to 600 terabytes. So that number is something that you can define as the total record limit. And then going down, we have the network adapters. Based on the number of ports that are connected, we'll show you the link speed and then whether you want to capture on those ports. And then there's drive information that's tied to each port. So in this case, this is a dual CPU setup that we're showing here. Each CPU has its own set of PCIe lanes that are directly tied to a set of disks, meaning the NVMe SSDs. So in this case, port 0 here is on CPU 1, and it has its own set of SSDs. I think we're showing 8 here. And then port 1, which is the second SmartNIC sitting on CPU 2, that has its own set of SSD that it's connected to. And the reason we're doing this is so each CPU has direct access to its own set of SSDs. That improves performance tremendously. If we're writing from the same CPU writes to its own set of disks instead of writing to the disks that are tied to the second CPU. So we sort of control or limit which disk you can use based on which CPU it's connected to. And in here, we'll show you the free space, disk space on each drive, sort of give you an idea how much total available storage that you have. So now we're looking at the hardware filter. So you can filter traffic. I think Vikram had mentioned earlier. We can filter based on the MAC address, VLAN ID, IPv4, IPv6. We can also filter on tunnel traffic. So if the traffic is let's say within a GTP tunnel, for example, we can also filter based on that. We can filter TCP, UDP, port numbers, and so on. So obviously 400 gigabytes, it's gigabits is a lot of traffic to capture at once. So if you don't want a huge file to be recorded, you can use the hardware filter to limit the type of packets that you're capturing. Okay, now we're showing the general statistics. So this is the overall statistic of all of the ports that you're capturing on. So we have a general statistics, and then we also have a separate port statistics that show you how much data is being captured on each port. So here we're given overall information of how long the recorder has been running, the layer 2 receive rate in gigabits per second, the record rate, which is how fast we're recording to disk. So you'll notice that in this screenshot that the record rate is higher than the layer 2 receive rate. That's because there's extra metadata information that we're capturing. So that also gets stored to disk. So that number will be a little bit higher than the layer 2 receive rate. Capture frame per second, so how many frames per second that we're capturing, the total captured frames. If for some reason there are frames that were dropped, we'll also show you that information here. That could happen, for example, if you're capturing, let's say, in a single CPU setup, in that portable system, if you're capturing more than 400 gigabits on a single SmartNIC, because of the PCIe limitation there, potentially you would see drops if you're capturing beyond what the PCIe limitation is. And then the recorded byte shows you how much total recording we have stored to disk. So now we have the port statistics, which shows you stats for each individual port. Again, we're showing you the total number of frames received, layer 2 receive rate, capture frame rate. Here we're also showing you the layer 1 receive rate, which essentially is the max, sort of the raw data rate that we have that we're seeing on the port. So layer 1 the layer 1 rate includes the sort of the overhead stuff like the preamble, the interframe gap, and so on. So that's 20 extra bytes that's added for each frame. So that number will be a little bit higher compared to the layer 2 rate, depending on the frame size. The larger the frame size, the smaller the overhead. So if you're capturing, let's say, 400 gigabits of 64 byte packets, that's going to be a lot of overhead needed for each packet, for each frame. So then the layer 1 will be high, but layer 2 will be much lower than what the layer 1 shows. Additional stats here, we have some other packets that will show you if there's something wrong with the capture. So I missed, I errors, packet discard. So those are sort of hardware level or software level drops that we may potentially see if you're capturing packets at a rate that's greater than what the PCIe 5.0 limitation is. If there's corrupted packets, we'll show that either as I errors or CRC errors. And then we have a sort of a breakdown of the different packet sizes that we received. So from 64 all the way to the max byte if it's a jumbo frame. So those are all shown here in this view. All right, so that's a continuation of the previous screenshot there. So this is showing if there's any errors, we would show that numbers here. Okay, so here's the graphical view of the capture. We're showing it on both ports. You can see here there's the sort of the teal line there that shows the capture rate. So in this case, we're seeing that we're capturing at 400 gigabits per second. If there's any drops or errors, that will show up in the graph. In this case, we're not showing anything here because it's a clean capture. So there's a rate graph that shows you the throughput, and then an error graph that would show you if there were any missed packets, drop packets for whatever reason. It will show you when those drops occurred. So we'll see this graph here is showing sort of a time. You can go back hours, days, and see when any missed packets occurred. Again, this is showing the rate graph here that shows the 400 gigabits capture. So this is when we first started the capture. You'll see that the capture rate was initially 0, and then we're simulating traffic, pumping out 400 gigabits worth of data to each port here, and we'll see that the capture rate is slowly ramping, or actually ramping up pretty fast to 400 gigabits per second. Again, showing no drops in this recording. So because the FastRecorder is recording data as sort of raw, in a sort of raw format, scattered across multiple disks, we use the packet extractor to sort of recombine all of that recorded data into a format that's readable by either our packet scan solution or by Wireshark. So we can combine it into, recombine the raw data into PCAP or PCAP-NG. So that can be extracted into a single large file, or we can break up the extracted files into multiple smaller sized PCAP files. So you can extract, there's some conditional filters that you can do when you extract. So obviously you don't want to extract the entire recorded file, because at 400 gigabits, that file gets very large very fast. So with some filters, you can extract based on either file size, time period, or packet count. You can determine or decide when you want to start the extraction. So based on a timestamp, you want to, let's say, start the extraction an hour into the capture instead of from the beginning. So you can define that information through the web interface. And then there's also option for packet slicing. So if you're not interested, for example, in the payload of the data that we recorded, and you just want to see sort of the header information, you can use packet slicing to reduce the size of each packet that you're extracting. And then we have some metrics and reporting that shows you how the extraction process is going, how many frames we've extracted, and so on. So the graphical view of these options here. So in the left side, we have the recording information, so including the name of the recording, when it was started, when it ended, the record duration, and then the total size that's stored to disk. So in this case, we'll see it's a 69 terabyte file recorded within 13 minutes. So during extraction, on the right side here, you see the configuration view. There's a time criteria, meaning you can decide when to start the capture, or when to start the extraction. The original capture start time was at 4:54 in this case. You can put a different time value here. So if you want to start the recording at 5 o'clock, for example, you can do that. You can also choose the end time. So that would be a way to limit the total number of bytes or packets that you're extracting. The limit criteria on the right here shows you can extract all frames, extract based on a certain size, packet count, or duration. Port filter, you can extract the packets from either port 0 or port 1 or 2 or 3, depending on how many SmartNICs you have on the system. And then in the operation here, there's options for packet slicing if you want to divide the extracted file into multiple files. There's also the option to compress the extracted files. So using a zip format, we can compress the extracted file so that it's even smaller and easier to move to another disk. And then the destination file name. So based on the SSDs that's on the system, you can extract the file into a certain drive with the provided name. So this is showing you the statistics as it's extracting. Obviously, the extraction time will be based on the how large the recorded data is. So if it's a very large data, it'll take a few minutes to extract all of the data. So in this case, we're showing that we're processed 83 million frames in about 2.5 minutes. So as it's extracting, we'll show you all of the rates information here, how many bytes we processed, how many we've extracted, and if there's any issues with the extracted frames, you can show here. The drive information shows you the sort of the number of recordings that you have already made on the system, which drives those data are or where we have stored the data. So if you have 20 disks, you can see based on the recording configuration, which disk we're writing to, and then how much total data each recording is. So from this view, you can also delete previous recordings if you need to free up the disk space. And then the next slide shows you the disk usage, how much free space is available on each drive, and how much data is used by the FastRecorder, right? How much data is used by that, how much is used by other things on the system. So this will give you an idea of how much free space you have, and when you do the recording, you can choose the available drives based on this information. Okay, I think that's sort of the overview of our web interface.
So I just want to remind everybody that if you have further questions, please email us at info@gl.com, and we can set up a web demonstration or a web conference and talk through your specific requirements. If you haven't already, please subscribe to our newsletter. So that is it. Thank you again for your time, and enjoy the rest of your day.